Hello, here we will discuss about basic statistics and main topics is measures of central tendency. So we'll discuss about measures of central tendency. There are few points we will discuss in coming slides. So first of all, we'll discuss about arithmetic mean, then we'll discuss about median, then we'll discuss about mode, we'll discuss of geometric mean and harmonic mean and weighted mean. If we are talking about measures of central tendency, so these 5 points is comes under measures of central tendencies: arithmetic mean, median, mode, geometric mean, and harmonic. And weighted mean is a one additional points, so we'll discuss, but only 5 points is important in measures of central tendency. Now, what is the central tendency? Measures of central tendency are also called as the averages, and they give us an idea about the concentration of the values in the central part of the distribution. So this is the basic meanings of the central tendency. Now, what is the methods of mean calculation? So as we know, summing up all the observation and divided by the number of observation, which is known as the arithmetic mean. So for example, following observations 12, 13, 15, 10, we need to calculate the mean value of this given observation. So how will get? So here x1 means x1, x2 up to xn. So here five observations. So n will take the 5 values. So we can say this is the x1 equal to 12, x2 equal to 13, x3 equal to 15, x4 equal to 10, x5 equal to 5. These are the observations. So we can calculate x bar is equal to x1 plus x2 plus x3 plus x4, and this is the x5. xn means here in that case x5, and divided by number of observation. And mathematically we can write it summation I equal to 1 to n xi divided by n, which is number of observation. Now we can find out x bar equal to all the observation we are adding here and dividing total number of observation. So once we'll add all the values, we'll get the 60 divided by 5. Here x bar equal to 12. So average value is 12. Mean value is 12. We can say this is the basic simple example for mean calculation, and this kind of the data is known as the ungrouped data. If we have ungrouped data and we want to calculate mean, so we can apply this formula for ungrouped data. Now next points, let's have example. Find the mean of statistics test score. Suppose some of the students appeared in the out of 100 marks in statistics and they have obtained certain numbers. So how will get the average marks of the students here? So we'll add all the values and then add all the values. We are getting 783. This is the total, and then divided the sum by the number of values. So number of values is here 9. So 783 divided by 9, so equal to the mean is 87. We can say average marks of the statistics is 87. Now next points, here we need to understand in measures of central tendency. When we are talking, in some points come the inferential statistics. So what is the meaning of inferential statistics? Means a group of the population, target populations, and out of target population some study population, and out of study population we are taking the samples. So that means once we are talking about the populations and we are going to calculate the mean for population, median for population, mode for population, that is known as the parameter. And once we are going to draw the samples out of that population with help of the certain sampling methods, and for that sample we are going to calculate mean, median and mode, that is known as the statistics. And there may be some variation because of in mode, there some may be variation because of the sampling error, and in median because of sampling error, and mean because of the sampling error. This is the basic concept about population and sampling. Population refers to parameter, refers to population, and statistics refers to sample. These things we need to know once we are going to analyze the data. Now, next points. What is the merits of arithmetic mean? We need to understand. It is rigidly defined. It is easy to understand and easy to calculate. And it is based upon all the observations, because we are adding all the values and divided by the number of observations. And of all the averages, arithmetic mean is affected least by fluctuations of the sampling. Now, what are the demerits? So, one more important point, sometimes described by saying the arithmetic is the stable average. And demerits of the arithmetic mean, it cannot be determined by inspection, nor it can be located geographically. Arithmetic mean cannot be used if we are dealing with the qualitative characteristics which cannot be measured quantitatively, such as intelligence, honesty, beauty. So once we have a quantitative information, then we can calculate arithmetic mean. But if it is a qualitative information is given, we cannot calculate mean. That is the demerits. And arithmetic mean cannot be obtained if a single observation is missing or lost or is illegible unless we drop it out and compute the arithmetic mean of the remaining values. This is the demerits point. Arithmetic mean is affected very much by extreme values. In case of string items, arithmetic mean gives a distorted picture of the distribution, and the longer remain representative of the distribution. Now some formula for mean calculation if we have a different data set. So if we have ungrouped data and group data, then which formula will apply? If we have ungrouped data will apply, we can calculate x bar equal to x1 plus x2 up to x1 divided n. And we are, and other way we can write summation I equal to 1 to n xi divided by number of observation. We have ungrouped data, we can go with that formula. But if we have a group data, then we can calculate x bar summation of I equal to 1 to n fi xi. Here f represents the frequency for that particular group, xi represents the number of observation, and divided by summation I equal to 1 to fi, and sometimes it is all and it is summation fi equal to capital N or small n, we can say, if we are using the sample data. Now, if value of x or f are large, the calculation of mean by group data formula is quite time consuming and tedious. The arithmetic mean is reduced to great extent by taking the deviations of the given values from any arbitrary point A. The formula we can say x bar equal to a plus 1 upon n summation I equal to 1 to n fi di, or we can more simpler, we can use a plus h divided by n summation I equal to 1 to n fi di. So these three kind of the formula we can use for the four kinds of the formula we can use for the mean calculations. Now we'll have example. We can find out the mean value. Suppose a survey of 100 families, each are having 5 children, reveal the following distributions. Find the mean of male children. Suppose 9 family members are having 0 children, 24 family members are having 1 children, 35 family members are having 2 children, 25 members are having 3 children, 6 family members are having 4 children, and 2 are having 5 children, and total is 100 families. Now we can calculate some fx value. So how will get the fx? This x multiply f will get this value. So all the corresponding value will multiply. 2 multiply 35, 3 multiply 25, 4 multiply 6, 5 multiply 2 equal to 10, and we'll add all the values, that is the 200. Now we'll use the formula x bar equal to summation fi xi, that means this value, and divided by summation fi means this value. We can use simple answer 200 by 100 equal to 2. So we can say here our aim is to, on an average, each family members are having 2 children. Now we'll go for next points. Suppose class interval is given here and frequency f is given. So how we'll calculate the mean here? So here, first of all, we have to find out the x, because x is not given. So we'll calculate the x column here, that is known as the mean value. How we'll get? We'll go for the class interval lower limit plus upper limit divided by 2. We'll get 4. Lower limit plus upper limit divided by 2 will take the 12. Same way 40 plus 48 divided by 2 will get the 44. This is the way we can find out the mid value. Now we'll get the fx column. So sorry, d x minus a divided by h, a equal to 2 8 and h equal to 8, and we'll just put the value here. So constant, generally we'll take the, how we'll decide the a value here. So we'll go for the x column, and middle class interval we can take the constant value, and this difference upper limit minus lower limit, that's value we can take the h value, and we can find out this column with help of this formula. And now next column we can find out EFD. This is the D column and this is the F column. We'll multiply corresponding value 8 multiply minus 3, which is minus 24. So correspondingly we'll get and we'll find out all the value. This is the total value summation FIDI, which is minus 25. Now we'll put the formula x bar equal to a plus h by n, I equal to 1 to n FIDI. We'll put all the values here and we'll get the simple x bar here. So this is the simple method for arithmetic mean calculation for group data we can find out. Now we'll go for the next point for median. Median is the 50th percentile of the distribution, or we can say the point where half of the observation fall below and half of observation fall above from the midpoint. In any distribution, there will always be an equal number of cases and above and below the median. So like this, if you can say balancing, we can find out the locations, mid value, we can balance it. So this is the basic concept of the median. Now we'll find out more points how to solve the median if data set is given. So the middle value in an ordered sequence of observations, that is to find the median, we need to order the data set and then find the middle value. So in case of an even number, suppose data set is given, we are arranging it ascending or descending order, and if that order is even number of observation, the average of the two middlemost value in the median we can find out. For example, suppose this 5 observation is given, find out the median value. First of all, we'll arrange the data in ascending or descending order. Then we'll find out the positional value n plus 1 by 2 if order is odd. If n is odd, number of observation is odd, then choose the middle values. Here n is a 6, n is a 5 plus 1 divided by 2, so 6 divided by 2. So equal to 3. So third positional value in given data set is 6. So the middle value is 6. Now if same way, if we have a data set is given and we have arranged ascending or descending order, and if series is even, then how we'll get the median value? So we'll use the n by 2 and n by 2 plus 1 position number. So here we'll go, the median is the average of the two middle values from the sorted sequence. So n by 2 in given data set is 5 and n by 2 plus 1. So 3 plus 1, fourth positional value in given data set. So what would be the median value? 5 plus 6 divided by 2 is 5.5. So this is the simple, if ungrouped data set is given and if observation order is even and if observation order is odd, then we can calculate median value like this. Now, what is the merits of the median? It is rigidly defined, it is easily understood and easy to calculate. In some cases, it can be located merely by inspection. It is not at all affected by extreme value. It can be calculated for distribution with open-ended class. And what are the demerits of median? We need to understand. In case of even number of observation, median cannot be determined exactly. We merely estimate taking the mean of two middle terms. This is the demerits, and it is not amenable to algebraic treatment. And as compared with the mean, it is affected much by fluctuation of the sampling, and it is not based on all the observation. For example, the median of 10, 25, 50, 60 and 65 is 50. We can replace the observation 10 and 25 by any two values which are smaller than 50, and the observation is 60, 65 by any two values greater than 50 without affecting the value of median. So this is the demerits, and this property is sometimes described by saying the median is insensitive. Now median, how to calculate the median for group data? So we'll use this formula, median equal to L plus within a bracket n by 2 minus cumulative frequency, bracket close, multiply H and divided by frequency, where L represents in the formula lower limit of the class interval where the median occurs. F represents the frequency of the class where median occurs. H width of the median class, and cumulative frequency of the class preceding the median class. Now find the median weight of 590 infants born in a hospital in 1 year. Details are, this is the weight in infants is given in class interval and number of infants is given. So that means this is the frequency is given already. Now we have to calculate the median. What is the procedure? So first of all, we have to calculate the cumulative frequency. As we aware how to calculate the cumulative frequency, 37 plus 117, 154 plus 207, 361, like that we can calculate the cumulative frequency column. Now we have to apply the formula and we can find out the each value of the formula, and sorry, we can find out the formula and calculate the median. So in that case, we have to total en is 590. So first of all, we divide en divided by 2, 590 divided by 2, which is 295. Then median class we have to find out where 295 belongs. So like we have to go through the cumulative frequency 295. So 295 will come here. So this would be our median class. So once we got the median class, then lower limit of that median class is the 3, and frequency, corresponding frequency is 207, H is 0.5, cumulative frequency is 154, and then put the formula as we are aware, put the value we can find out the median value is 3.34 in given data set. Now we'll go for the one concept here. The median is less sensitive to outlier extreme score than the mean, thus better measures than the mean for highly skewed distribution like family income. If we have given observation this kind of the data, so we can calculate mean or median. So if such kind of the data and some data is outliers fluctuating, so we can calculate the median in place of the mean. Now, for example, the values of the given, find out the middle values. So we can just arrange ascending and descending order. We can find out the median value. So the median is for given data set is 88. So we can interpret half the numbers are less than the median and half the numbers are greater than the median. This is the basic interpretation of the median. Now we'll go for the mode. So mode is means most often value or most frequent value in given data set, that is known as the mode. Now we'll have to calculate the mode. Suppose this data is given and we have to find out the mode. So there is each values are independent. There is no repetition. So there is, we can say there is no mode in given data set. And second row we can see there is the this 4.9. 4.9 is a repeating 3 times. So we can say there is the one mode. 4.9 is most frequent value in given data set. Now more than one mode we can find out. If in this data set 28 is repeating 2 times, 43 and 43 is repeating more than 2 times. So we can say here more than one mode in given data set. Now we have merits of the mode. So mode is readily comprehensible and easy to calculate. Mode is not at all affected by extreme values. Mode can be conveniently located even if the frequency distribution has class interval or unequal magnitude, and open in the classes also do not pose any problem in the location mode. Mode is the average to be used to find the ideal size. And demerits, mode is ill-defined. It is not based upon all the observation. It is not capable for further mathematical treatment as compared with mean. Mode is affected to a great extent by fluctuation of sampling. Now we have to calculate mode for group data. If we have group data, then how we'll calculate the mode? We'll use this formula L plus Fm minus F1 divided by 2Fm minus F1 and F2 and multiply. Yes, sometimes this formula is we can calculate mode. Some another formula we can find out equal to L plus within a bracket D1 plus D1 divided by D1 plus we can say D2 and bracket close and multiply by H. So this way we can find out also mode. So F1 is a frequency just lower model class. F2 is frequency the upper mode class. Fm is the mode frequency, and L is the lower limit of model class, and C is the class difference. C, or we can say here H and C means both meaning is same. So this is the formula we can use for mode. Now how to calculate the mode? We can say example IQ level of the IQ is given and corresponding frequency is given. So 92, there are 11 persons which IQ level is 90 to 100, 27 persons whose IQ level is 100 to 110. Like that all the IQ level is given corresponding. Now model class 130 to 140 is given. 130 is 140 given. The FM is the most frequent maximum frequency we have to find out 43. F1 is the 38, F2 is the 28, and C is the means lower limit minus upper limit, sorry, upper limit minus lower limit, which is the C, or we can say H as given formula, which is 10, and L is 130 lower limit of the model class is the L. Now we can use this formula mode equal to L plus this same formula we can use. We can put the value here in this equation and we can find out the mode for given data set. This is the basic simple methods we can calculate mode. Now we'll discuss about geometric mean. So this measure of the central tendency is called the geometric mean and is defined as the arithmetic mean of the value taken on log scale. Geometric mean can also be interpreted as the nth root of the product of n observations. Like geometric mean is defined as the positive root of the product of observations. Symbolically, we can say g equal to x1 multiply x2 multiply x3 up to xn whole power 1 by n. It is also often used for a set of numbers whose values are meant to be multiplied together are exponential in nature, such as data on the growth of the human population or interest rate of a financial investment. So geometric mean for group data, if we have group data x1, x2, xn observation, f1, f2, fn, frequency is given x1 to power f1, x2 to power f2, xn to power fn whole divided by, this is the product I equal to 1 to n xi to power fi 1 by n and n equal to summation fi. This formula we can apply. Now for ungrouped data, if we have ungrouped data, we can use geometric mean for g equal to x1, x2, xn under root. We can use this formula. And if we have a group data x1 to power f1, x2 to power f1, x2 to the power f2, xn to power here, it would be the fn. And then we can take the under root, we can find out. And otherwise, same things we can use the g with help of the logarithm nt log 1 by n I equal to 1 to n log xi, or if we have a frequency group data nt log 1 upon n summation I equal to 1 to n fi log xi. These things we can apply this formula. Now, for example, if we have 20, 25, 15 bits kg for 3 children is given, the geometric mean of these 3 observation will be cube root of the product. So we can find out geometric mean this 1 by 3 and we can take the logarithm value and we can find out our root value we can take and we can find out the geometric mean. Now, geometric mean is used more in microbiological or serological research. One major limitation of geometric mean is that it cannot be obtained if any observation is zero or negative, as the log value of such observations are not defined. Now, harmonic mean, another measure of central tendency of frequency distributions called harmonic mean, is based on the reciprocals of the observations. It is defined as the reciprocal of the arithmetic mean of the reciprocal of the observations. So we can say harmonic mean equal to 1 divided by 1 upon n summation I equal to 1 to n 1 upon xi. This is the basic formula we can use if we have an ungrouped data set. And the use of harmonic mean is appropriate when the reciprocals of the observation seems more useful to determine the central tendency. Harmonic mean may be used to compute the average of rates, saying typing speed, number of words per limit, speed of the car, kilometer per hour. It is used very rarely in medical and biological applications. Now, if we have ungrouped data, we can use simple this formula, and if we have a group data, then we can use this formula. Only we have to multiply the frequency columns. Now, if what is the harmonic mean of this given data set 1, 5, 8, 10? So we can use n equal to 4 formula we are already aware. So s equal to 4 divided by 1 upon 1, 1 upon 5 plus and we'll simple arithmetic we can calculate and we can find our arithmetic mean is equal to 2.80. So one more examples. If a driver drives a car at 25 kilometer per hour for the first hour and 30 kilometer per hour for the second, what is his average speed? So we need harmonic mean 2 divided by 1 by 20 plus 1 by 30. We can solve it. We can say 24 kilometer per hour, miles per hour. Now we'll talk about one more points, which is the weighted mean. So what is the weighted mean? Sometimes we wish to average numbers, but we want to assign more importance or weight to some of the numbers. The average you need weighted average. Weighted mean, the weighted mean of the positive real numbers x1, x2, xn with their weight w1, w2, wn is defined by x bar equal to summation I equal to 1 to n wi xi divided by summation wi. Sum of the, in other words, sum of w is the weights, x is the value or observations, we can say. So a weighted mean is a kind of average. Instead of each data point contributing equally to the final mean, some data points contribute more weight than others. If all the weights are equal, then the weighted mean equals the arithmetic mean, the regular average you are used to. Weighted means are very common in statistics, especially when they studying population. Steps: multiply the numbers in your data set by the weights. Add the numbers in step 1. Set this number aside for a moment. Add up all the weights. Divide the numbers you found in step 2 by the number you found in step 3. So, for example, if you take 300 points exams in your statistics class and score 80, 80 and 95. The last exam is much easier than the first two. So your professor has given it less weight. The weights for the three exams are, so exam 1 40% of your grade, and exam 2 40% of your grade, and exam 3 20% of your grade. So multiply by the number. So these value we can multiply, and this is the weighted marks 32, 32, 19. Add the numbers up to 32, 32, 19, so which is 83, and this value is 1. So we can say average weighted average marks is 83. So now next points will talk about find the simple and weighted arithmetic mean of the first n natural numbers. The weighted mean the corresponding numbers. The first natural numbers 1, 2, 3 dot dot n. So 1 plus we are n. So we can find out if we are adding n natural numbers, that would the we can find out n within bracket n plus 1 divided by 5. And if we are adding individual squares of n natural numbers, so this formula n plus 1 2n plus 1 divided by 6, this formula we can apply. And simple arithmetic mean we can find out summation x divided by n plus 1 divided by 2. Weighted arithmetic mean we can apply this formula, and squares we can do it. And n plus 1 2n plus 1 divided by 6 multiply 2 divided by n plus 1. So weighted arithmetic mean is 2n plus 1 we can use. So this is about weighted mean. So one examples we can find out which set of data has one mode. There are 3 points is given. So we can say this data have a one mode. Now which set of data has no mode? Say A, B, C. We can see carefully. We can found A is the no mode. There is no repetition, no frequency. And which set of the data has more than one mode? So we can say this C has more than one mode because 18 is repeating and 7 is repeating. So this is about measures of central tendency. We can have basic idea, and if we want more things, we can explore more examples, and we can solve more questions, and we can apply it in apply fields. Thank you.